Hello. This is our topic today. Today's topic is this one: how the universe lost its antimatter. How the universe lost its antimatter means where did all the antimatter go? And of course, this is a cosmic mystery. Okay, if you study cosmology, then you will find this topic. It's a cosmic mystery. In particle physics also this is taught. So the problem is what? According to the theories developed so far by the physicists, it is estimated that, or it is hoped that the presence of matter and antimatter in the universe should be in same amounts. Okay, but whenever we are searching for the antimatter, we are means here the physicists, I am talking about the physicists, they have searched for the antimatter and they found that the amount of antimatter present in the universe is very, very less than the amount of matter present in the universe. So why such discrepancy is coming into the picture? That is the question, and that is called the cosmic mystery. We know that the properties of antimatters, we know the difference between the matters and antimatters. They are just opposite in their characters. Okay, you know matter, you have idea about matter, and what is antimatter? I think you have this idea also. Matter means it is composed of mainly protons, electrons and neutrons. Neutrons are chargeless. Protons and electrons are charged particles. Protons are having positive charges and electrons are having negative charges. And antimatter of these particles means these are matter. Okay, antimatter of these particles have the same character but charges are opposite. There is similarity between the quantum characters also. Okay, so anti-electron is there. Anti-electron is called positron. Another name is, a different name is given. Anti-electron means positron. So since electrons are having negative charges, then positrons are having positive charges. Protons are having positive charges, therefore antiprotons are having negative charges. And you know that neutrons are chargeless, so antineutrons are also chargeless. And what is the main thing here? Main thing is that whenever a matter comes in contact with antimatter of its antimatter, okay, say a proton is coming into contact with antiproton, then what will happen? Then annihilation. There will be annihilation. They will be annihilated. And a tremendous amount of energy will be produced. How much is the energy? It can be estimated by using the famous Einstein's famous equation E is equal to mc square, where E is the energy, m is the mass, and c is the velocity of light. So using this equation, you can easily calculate the amount of energy produced by converting the mass into energy. Okay. So whenever matter and its antimatter comes in contact with each other, they will annihilate each other and energy will be produced. So these things are known to you. But according to the theories developed by the physicists, the matter and antimatter, the amount of matter and antimatter should be same in the universe. But we have observed that these are not same at all. Amount of antimatter present in the universe is very, very less than the amount of matter present. So what is the reason behind this? Though the answer to this question is what is the reason is not clear. Still it is not clear. Okay. Still researches are going on in this field. Okay. But physicists have given some ideas about the probable causes of this problem. This problem is known as baryon asymmetry problem. So what is the cause of baryon asymmetry problem? For this thing, there are few reasons. Now, 4 number of reasons are there. I have written here. First reason is called CP violation. CP, C for charge, P for parity. Okay, CP violation. This is point number 1. Point number 2 is Sakharov conditions. Sakharov conditions. Sakharov condition. This is one Russian physicist, Andrei Sakharov. He proposed these 3 conditions. If these 3 conditions are prevalent, then in that case, baryon asymmetry problem will be observed. What are the conditions? Baryon number violation. Violation of baryon number. Next comes C and CP violation. Again, I have already mentioned C for charge and CP for charge parity. Okay. Then comes point number 3, that is departure from thermal equilibrium. If these conditions are met, then there will be baryon asymmetry. So according to this scientist, Andrei Sakharov, Russian physicist, okay, according to this scientist, in the early universe, means just after the Big Bang, we know the universe was created through that great phenomenon, Big Bang theory, okay, you know this thing. So just moments after the Big Bang, this means there is a chance that these conditions were met, okay, and due to these conditions, we can observe the baryon asymmetry problem. Means we can observe the asymmetry between the amount of matter and antimatter in the observed universe. Okay. Number 3 is electro-weak phase transition. This is one more problem. According to this theory, electro-weak phase transition, this happened just after the Big Bang, and it might have created, I should not say that it created, I should say that it might have created regions of space with different properties for matter and antimatter. Okay, and that is the reason behind this asymmetry, means baryon asymmetry. That is the reason. Okay, so these are ideas. There is no experimental verification of these theories. Okay, last comes grand unified theories. You know that means in particle physics, standard model of particle physics is followed, but grand unified theory is somewhat different from the standard model of particle physics. And according to the grand unified theory, means in theories you will find that they are proposing, according to their theory, okay, according to their theory, means grand unification theory or grand unified theory, according to their theories, they are proposing that it is obvious that amount of matter and antimatter will be different. Means it is inbuilt in the theory. According to that theory, amount of matter and antimatter are not same, means should not be same. Okay. So in this theory that is inbuilt. But whether that theory is correct or not, that is still not known to us. So researches are going on. Okay. And the first point I have already told you. So there are a total of 4 points. CP violation means again say that charge parity violation theory. Okay. So these are the probable reasons. These are not the reasons. You don't ever say that these are the reasons behind this topic. That is how the universe lost its antimatter. Means according to the title, in the beginning of the universe, amounts of matter and antimatter were same. But with time, okay, the amount of antimatter has decreased. And at present, we can see that there is very, very, very less antimatter present in the universe as compared to the amount of matter. Okay, so these are the probable reasons. Okay, these are not the exact reasons. There is no experimental verification of this. Okay, anyway, so this is the end of this lecture. Thank you for watching this video. And if you like my videos, please press the like button and try to subscribe to my channel. Okay, thank you for watching this video.